So the idea behind the selection sort algorithm, as the name selection is, select the smallest element in the list or find the smallest element in the list or in the array. After finding that element, exchange the same with the element in the first position. Now find the second smallest element and exchange it with the element in the second position. And this process will continue until the array is sorted. So let's suppose we are having this array, and these are the index values, and suppose the number here is 5, 9, here 2, here 1, and here 3, like this. To find the smallest element, so initially we will work on the whole list. Okay, तो जैसे जैसे लिस्ट इसमें सॉर्ट होती जाएगी, फिर हम क्या करेंगे, उस अकॉर्डिंग जो हमारी बची लिस्ट होगी उस पर वर्क करेंगे. So in this list, initially we need to find out the smallest element. तो अभी तो हम विजुअली देख लेते हैं, फिर हम जो हमारा एल्गोरिथम है उसके अकॉर्डिंग इसको प्रोसीड करेंगे. ठीक है. सो यू कैन सी हियर द स्मॉलेस्ट एलिमेंट इन द लिस्ट इज 1. So what will happen? This 1 will be exchanged with the 5. So in the past 1, this 1 will exchange with 5, and our array will be look like this. It will be 1, 9, 2, 5, and 3. So this element, this is the smallest element in the past one. It is placed at its appropriate position or the first position. Now the unsorted list is this one. Again we need to repeat the same procedure. और कब तक करना है? Let's suppose ये index values हैं, so the loop will execute from 0 to 3, because जो last में बचेगा वो तो automatically अपनी position पर ही होगा. So from this list again we need to find out the smallest element, as this one is the smallest element. So this will be exchanged with this. So 2 will come here and 9 will come here. Now this list is sorted and this one is unsorted, and we'll repeat the process till the list is in sorted order. Okay, so in the case of sorting algorithm, the running time depends only slightly on the amount of order in the file, like the list is in sorted order or the unsorted order. It is a stable algorithm and it is an in-place algorithm. In place means there is no need for the we can say there is no need for extra memory for executing this algorithm. So there are basically, if we categorize algorithm in terms of memory requirement, extra memory requirement, then there are two categories: in place and out place, or not in place. So in place algorithms can execute within the storage which is already allotted to the algorithm, and the out of place algorithms require secondary memory while executing. So this insertion sort, selection sort, and bubble sort, these are the in-place algorithm. And if we are talking about the example for out-place algorithm, then that is the merge sort algorithm and the modified version of the merge sort algorithm, where we are having a lot of data that cannot be placed in the main memory. So in that case, we need to place the data in secondary memory, and we need to shift the data from secondary memory to main memory, and after sorting again we place the data into the secondary memory. तो जैसे जैसे requirement के according वहाँ पे memory की requirement है. So that is the example of outplace algorithm, that is merge sort, and normal, that is not the normal merge sort, that is the modified merge sort. So let's suppose we are having this example. We can see here initially what is the process. Find out the minimum element from the list. So this one is the minimum element, and place this element at the first position. So 8 will come here, 1 will come here. Now again find out the minimum element from the list. So now we will work on this list. So you can see here 2 is the smallest element and it will be replaced with 4. तो 2 will come here, 4 will come here. तो जो हाईलाइटेड है ये लिस्ट ये sorted होती जा रही है, and the unhighlighted elements are unsorted, and the circled elements are those which are the minimum element in that particular list. So 6, 9, 4, 3, 8, minimum element is 3. It is with exchange with 6. So 3 will come here. Now 9, 4, 6, 8, minimum element is 4. It is exchange. It will exchange with 9. Now 9, 6, 8, minimum element is 6. 6 will exchange with 9. Now 9 and 8, minimum element is 8. It is swapped with 9. Now there is only left one element left. So it will be, and this will be the minimum element in that particular list, and this will be the sorted list using this selection sort procedure. Now let's come to the pseudo code for this. So this is the pseudo code of the algorithm. So we are just giving input of the array in this particular list. So initially we will calculate the length of the array. What is the length of the array? N equal length of A. Now means number of elements in the list. So here we can see here 0, 1, 2, 3, 4, 5 and 6. So total number of elements are 7, and these are the index values. So we will start a loop from j equal 1 to n minus 1, means up to 6. So we will take a temporary variable for intermediate calculation. So the name for that variable is smallest or small. We can take it anything. We can take it min, smallest, minimum, any according to you. तो लूप कहाँ से कहाँ तक चल रहा है? लूप चल रहा है j equal 1 to n minus 1, and this is the smallest. This variable will contain the value of the smallest element. Now this is another loop within this particular algorithm. This is the outer loop and this is the inner loop. So it will execute and depends on the value of the outer loop. I equal j plus 1 to n. यहाँ पे हम क्या करेंगे? यहाँ पे हम कंपैरिजन करेंगे. तो इनिशियली हमने अज्यूम किया जो फर्स्ट एलिमेंट था दैट इज द मिनिमम एलिमेंट, और फिर हमने क्या किया? एरे को स्कैन किया फ्रॉम फर्स्ट टू लास्ट, और फिर एलिमेंट्स को कंपेयर करते जाएंगे, और जैसे ही हमको कोई दूसरा स्मॉलेस्ट एलिमेंट मिलेगा, लाइक जैसे डू इफ ए ऑफ आई एट सम प्लेस ऑफ आई, जो स्मॉलेस्ट एलिमेंट है वो बड़ा है उस एलिमेंट से, देन व्हाट वी विल डू, वी सिंपली change the index value. The smallest will be I, and we will exchange the elements a of j equal a of smallest. तो हम क्या करेंगे? We will find out the location of the smallest element in the array, and after finding that location of the smallest element, we finally swap that element with the first element in that particular list on which we are working on. So initially this will be the list. So सब हम अज्यूम करेंगे इनिशियली दिस इज द स्मॉलेस्ट एलिमेंट, और फिर इसको हम कंपेयर करते जाएंगे. तो दिस इज द स्मॉलेस्ट एलिमेंट नेक्स्ट, एंड सपोज इट इज 0, है ना, एंड द लोकेशन ऑफ दिस मेन इक्वल 0. तो लूप चलता जाएगा. ए ऑफ दिस विल बी कंपेयर्ड विद दिस. तो ए ऑफ min से कंपेयर हुआ है ए ऑफ आई, लूप चल रहा है 1 to n minus 1. तो बेसिकली ये तो क्या होगा? नंबर ऑफ पासेज के लिए है, और ये है नंबर ऑफ कंपैरिजन के. नंबर ऑफ पासेज मीन्स जे इक्वल 1 के लिए सबसे छोटा एलिमेंट फर्स्ट पोजीशन पे आ जाएगा, जे इक्वल 2 के लिए नेक्स्ट एलिमेंट इस सेकंड पोजीशन पे आ जाएगा, एंड सो ऑन. So initially the location of the min is 0, and this element will be compared with this next element, as this is small element, so the min will be changed to 1. Then again this will be compared to this, then no change in the min. Then this element will be compared to this, no change in the min. Then this element will compare to this. So 2 is less than 4, so it is 1, 2, 3, 4. So min will be 4. Now this a of min 2 will be compared with 3, no change in the minimum location index value, and 2 is compared with 1. So again we find a minimum element as compared to this, so the location of this min will be changed. So this will become 5 and 6, it will become 6. So min will be 6. So initially in this particular list, we have found out the allocation of the minimum element or the smallest element. जैसे यहाँ पे हमने किया, तो लास्ट में क्या होगा, स्मॉलेस्ट जो हमारा ये एलिमेंट की इंडेक्स वैल्यू है वो चेंज हो जाएगी, और फिर हम क्या करेंगे, वी सिंपली रिप्लेस दैट विद द स्मॉलेस्ट एलिमेंट एट द फर्स्ट पोजीशन इन दैट पर्टिकुलर लिस्ट। जैसे जिस भी लिस्ट के लिए हम काम, जिस भी लिस्ट में हम काम कर रहे हैं, j इक्वल टू 1 से स्टार्ट हो रहा है तो इनिशियली ये होगा, जब j इक्वल 2 होगा तो इनिशियली ये नेक्स्ट ये होगा, इस तरह से। तो द टास्क इज फाइंड आउट द मिनिमम एलिमेंट इन द लिस्ट एंड एक्सचेंज इट विद द फर्स्ट एलिमेंट इन दैट पर्टिकुलर लिस्ट। अब इसकी कॉम्प्लेक्सिटी की बात करें, देन द कॉम्प्लेक्सिटी ऑफ selection sort algorithm, as you can see here, there are two loops are executing. This is the outer loop and this is the inner loop. So it is executing j equal 1 to n minus 1 time, it is executing I equal j plus 1 to n time. So the complexity of this particular algorithm will be order of n square in the worst case. तो जैसे हमने notations के form में इनको describe किया था, so normally we focus on the worst case time complexity, means what will be the maximum time requirement. Okay, so in the selection sort, the maximum time requirement will be in the order of n square. So we can understand it by an animation. So मैं थोड़ा सा इसमें modification कर देता हूँ. Suppose we are having 10 elements. Okay, so selection sort के लिए आना है हमें यहाँ पे. So the minimum value initially is 22 and the first value is 81 in the unsorted list. तो हमारी क्या होगा इसके अंदर, इनको आपस में ये swapping हो जाएगा. These will be swapped. Next again we'll find out the minimum element, that it is 24. It will be swapped with 1. तो ये तो इस array के अंदर है, जैसे कि यहाँ पर ही थे इनिशियली जो मिनिमम एलिमेंट थे, जरूरी नहीं कि उनको आसपास ही मिले. अब जो नेक्स्ट मिनिमम एलिमेंट होगा दैट विल बी 28 and this 28 will be swapped with 81. So this will be 28 and it will be swapped with 81. Okay, next next minimum element we'll find out in this particular list. जैसे 86 to 79 की बात करें, then it is 34, then 34 will be swapped with 86. नेक्स्ट वन इज 40, वो अपने एक्यूरेट पोजीशन पे है. नेक्स्ट 46, next 46, it is already in at its appropriate position. Next one here 79 will be swapped with 81. Next one here 81 swapped with 86. Okay, so list is in the sorted order now. तो वो जो भी हमने स्टूडियो कोड देखा था एल्गोरिथम का, तो this particular array starting from 1 we are assuming as per this algorithm, but अगर इसको हम 0 से assume करेंगे then we need to modify it. तो ये हमारा जैसे 1 to n minus 1 एग्जीक्यूट हो रहा है, मीन अप टू हियर एग्जीक्यूट हो रहा है, जब इसे हम 1 से assume कर रहे हैं. तो 0 से होगा तो ये हो जाएगा जो भी साइज है उसका, that is n minus 2, and in this case it is 1 to n minus 1. So any doubt anybody in the procedure of the selection sort और द कॉम्प्लेक्सिटी कैलकुलेशन में हम ज़्यादा डिटेल में नहीं जाएंगे इसमें, हाउ टू कैलकुलेट दिस कॉम्प्लेक्सिटी में बस आई कैन जस्ट गिव यू a simple idea. This outer loop is executing n times and this inner loop is also executing n times. तो initially क्या होगा, it will execute from j equal 1 to n minus 1. तो अगर इसको हम देखें तो ये कितनी बार एग्जीक्यूट हो रहा है फॉर वेरी वेरी लार्ज वैल्यू ऑफ n. जैसे हम इनको asymptotic notations में describe करें, so if you want to express the time complexity in the asymptotic notation, then for the worst case we will take big O notation. Okay, so this loop for very very large value of n, हम normally जो notations में इसको represent करते हैं, then the input n is very 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 large, very very high. So in that case, so this outer loop will execute for n time and this inner loop will also execute for n time. So n into n, the total contribution, or we can say the complexity of this particular selection sort will be O of n square.